Hello dear student. Now I am going to discuss bi and tri heterocyclic ring with their numbering. This is the last lecture of our common heterocyclic ring series. Previously we have discussed 5-membered heterocyclic ring, and then in next lecture we have discussed 6-membered heterocyclic ring. Now we will discuss some of the important bi and tri heterocyclic ring. The first compound in this bi and tricyclic heterocyclic ring structure is indole. Indole is made up of benzene and pyrrole. Benzene and pyrrole. The structure look like this. This is your benzene and this one is your pyrrole. We have already discussed the structure of pyrrole in previous lecture. Now the numbering begins from this nitrogen: 1, 2, 3, 4, 5, 6 and 7. This is indole. Now a similar structure next structure is indoline. In indoline, the double bond between position 2 and 3, 1, 2, 3, 4, 5, 6 and 7. The double bond present in between 2 and 3, this double bond gets saturated, so there is no double bond in at position between 2 and 3. So this structure is known by the name indole. Now similar to this, if we shift this nitrogen from first position to second position, then the structure so obtained is this structure is known by the name isoindole. Why it is called isoindole? Because it is the isomer of indole. In indole, the nitrogen is at first position, but here it is at second position. The numbering begins from this: 1, 2, 3, 4, 5, 6 and 7. The next structure is benzimidazole. Benzimidazole is made up of benzene plus imidazole. So this is your benzene and this is your imidazole. Numbering again begins from this: 1, 2, 3, 4, 5, 6 and 7. This is your benzimidazole. The next structure is quinoline. Quinoline is made up of benzene plus pyridine. So here this is your benzene and this is your pyridine. Again, the numbering start from this nitrogen. 1, 2, 3, 4, 5, 6, 7 and 8. Now, next structure is isoquinoline. As it is clear from its name, isoquinoline is an isomer of quinoline. So, how the structure looks like? Quinoline is made up of benzene plus pyridine, but here the nitrogen shift from first position to second position. In this structure, the numbering begins from this position: 1, 2, 3, 4, 5, 6, 7 and 8. This is isoquinoline. Now, the next structure is quinazoline. Quinazoline is made up of benzene plus pyrimidine. So here is the structure of benzene and this is the structure of pyrimidine. The numbering of this quinazoline begins from this nitrogen: 1, 2, 3, 4, 5, 6, 7 and 8. This is quinazoline. Now, the next structure is phthalazine. Phthalazine has a structure like this. Again, the numbering begins from this position: 1, 2, 3, 4, 5, 6, 7 and 8. This is phthalazine. The next structure is pteridine. Pteridine is made up of pyrimidine plus pyrazine. Its structure is like this. The numbering of this molecule begins from this nitrogen: 1, 2, 3, 4, 5, 6, 7 and 8. Next structure is acridine. Acridine is a tricyclic nucleus. This one. The important thing is from where we number this ring structure. So traditionally the numbering given to this agridine is from here 1, 2, 3, 4. Now fifth is not given to this nitrogen. Fifth is here. Fifth, 6, 7, 8. And this one is your 9 and nitrogen is given 10 position. This is very exceptional molecule, acridine. Now similar to this, there is another molecule which is also tricyclic. Its name is phenothiazine. Phenothiazine. The structure of phenothiazine is like this. Now again, from where we should give numbering to this molecule. So here again there is an exception. The numbering given to from this position 1, 2, 3, 4. Now sulfur is given 5th, 6th, 7th, 8th, 9. And again the nitrogen is given 10th position. This is your phenothiazine. Next structure is of purine. Purine has this type of a structure. Now this molecule also have very exceptional numbering. The numbering start from this nitrogen 1, 2, 3. Now in this case we give numbering to this junction point 4, then 5, then 6. Then this nitrogen is given 7, 8 and 9. This is your purine, very exceptional. Now the next molecule is tropane. Tropane has a structure like this. Tropane. Now in tropane the numbering begins from this position 1, then 2, 3, 4, 5, 6, 7, and the last one is 8. This is the structure of tropane. This is the structure of tropane. So these are all the bi and tri heterocyclic ring with their numbering. You have to remember the structure and you have to mug up the numbering of this different ring. Why it is given this type of numbering is beyond the explanation of your class, but you have to mug up the numbering as it is. It is very beneficial for you guys to draw the structure of those drugs molecule which contain this nucleus, and you can easily give the IUPAC name to those structure or those drug which contain this nucleus. So from the next lecture onwards, we will discuss some of the important medicinal chemistry topic with synthesis of some important drugs, their SAR, and classification of some important category of uh, medicinal agent as per your PCI syllabus. This is all from today's class. Thank you.